Hello everyone, welcome to the series and parallel resonance practical in the Laboratory Practice 1 module of Semester 2. So let's get started with a basic introduction on the theory parts that are needed in order to understand the practical. First, let's understand what electrical resonance is. Electrical resonance occurs in an electric circuit when the reactance of the circuit elements cancels each other. The frequency at which this happens is known as the resonant frequency. At resonance, the inductive reactance and the capacitive reactance are of equal magnitude, so we can equate them to get the resonant frequency F0. There are two types of resonance occurring in an electrical circuit, which are namely series and parallel resonance. Series resonance is a condition that usually occurs in series circuits where the net reactance is zero and the impedance is at its minimum. Here the current flowing in the circuit is maximum for a given voltage and is in phase with the voltage, resulting a unity power factor. Parallel resonance is a resonance condition that usually occurs in parallel resonance circuits where the net susceptance is zero. As the admittance is at its minimum, the circuit current is maximum in parallel resonance. For a resonance circuit, we can define the parameter bandwidth as the range of frequencies for which the total power is more than half of the maximum power. Bandwidth of a series circuit is given by the band of frequencies which lie between 2 points on either side of its resonance curve, where current is 1 over square root 2 times of its maximum value at resonance. Resonance can be important in many different areas. In electrical systems, resonance can be used to filter out or select specific frequencies across a spectrum. So it is used for tuning in oscillator circuit, radio receivers, and television sets. Resonance also contributes to signal processing and voltage magnification. Up to now, what we saw was the introduction to the practical. Now let's start the procedure. In this practical, we will be mainly focusing on series resonance. The main equipments that are needed for the practical are the signal generator, oscilloscope, milliammeter, voltmeter, 1 millihenry inductor, 6 microfarad capacitor, rheostat, which can be used to give 50 ohms and 100 ohms. Using the mentioned equipment, the circuit for the series resonance should be built according to the following circuit diagram. The actual connections will look as follows. The non-grounded terminal from the signal generator is connected to one end of the capacitor. The other end of the capacitor is connected to the inductor, and the inductor is then connected to the rheostat of 50 ohms. The other end of the rheostat is connected to the milliammeter, where in this apparatus we have used the scale 25. The other end of the milliammeter is connected to the ground terminal of the signal generator. The voltmeter is connected in parallel with the signal generator output, and we have used the scale of 15 in this apparatus. The X channel of the oscilloscope is connected to the output of the signal generator. The Y channel is connected in between the inductor and the rheostat. It should be noticed that the Y channel is not grounded as the X channel was already grounded. First, power up the circuit and turn on the oscilloscope. You will see that the channel 1 has 1 volt scale while channel 2 has 500 millivolt scale. Then turn on the signal generator and you will see frequency generated by the equipment. Using the signal generator, we can go for a sinusoidal wave, a square wave, or a sawtooth wave. In this practical, we will be using sinusoidal waves. Next, we have to increase the voltage amplitude until the voltmeter shows 1 volt. Then you will see the two voltage waveforms with respect to time in the oscilloscope. To get the XY plot, press the menu and select the XY option. After getting the XY plot, change the appropriate knob to make the image more clear. As the starting frequency, we can give 50 Hz to the circuit. Then the oscilloscope plot would be as shown. The current reading can be taken using the milliammeter connected. Now let's increase the frequency to 100 Hz. Then the XY plot would change as follows, and the current value can be read again using the milliammeter. Just like that, we can increase the frequency step by step until the resonance frequency occurs. For each frequency value, we must get the XY plot and the milliammeter reading. At the resonance frequency, the area of the XY plot becomes 0. Now let's increase the rheostat up to 100 ohms. Then repeat the same procedure. Again, for each of the frequency values, the XY plots and the milliammeter readings should be taken. Increase the frequency once again step by step until the resonance frequency is met. When the frequency is increased beyond the resonant frequency, the area inside the XY plot starts getting increased once again. These are the observations obtained for series resonance. A and B was calculated by using the XY plots from the oscilloscope. For the calculations in this coursework, you are required to find the phase angles for each frequency value when R is 50 ohms and 100 ohms. Then the following plots should be drawn. By using the following equations, you can calculate the coil resistance value. As for the discussion, you should answer the following questions in your coursework. With that, we have come to the end of our practical. Hope you enjoyed learning about series and parallel resonance. Have a great day. Thank you.